Hello, today I want to go over just the equation of a parabola, a few questions you might come across on a quiz or test of mine in this chapter. So let's take a look at a specific problem, and that's when I give you the vertex of a parabola and then a point that is on the parabola. So in this case, the point that's on there is 2, 9. Now, if we're looking at the standard form, sometimes this is called our vertex form. So standard form or vertex form, we've got several variables here in this equation. The x and the y stand for any point that is on the parabola. Any point can go in for right there. The h and the k stand for the vertex of the parabola, and the a is like that stretch factor. So is it stretch vertically, or does it compress it, or does it flip it? So a lot of times we don't know the a in a situation like this. In fact, we don't know here, but we do know the vertex, and we also know a point that goes through it. So what we can do is label that vertex HK and label the point that it passes through here XY. And now I can substitute all of this into this equation and figure out what my A value is. So that's what I'm going to do here. I'm going to say, okay, my Y value is 9. My A value I don't know. I'm going to leave that as my variable that I got to solve for. The x value is 2, and I'm subtract from it my h value here, which is 1. Square it and add my k value. In this case, k is negative, so it's going to look like a subtraction symbol there, and it's going to be minus 8. And now I'm going to say, okay, 2 minus 1 is 1. So I've got 1 squared times a minus 8 equals 9. I'm still getting a by itself, so I'm going to add 8 to both sides, and I get 17 is equal to a. In this case, 1 squared, we've got 1 squared, which is just 1. And so I don't have to divide both sides by a number there. And I've got my a solved for. Now, this is not the answer to my problem because the question is asking to write the standard form of the parabola. But I needed to know my a value before I could do that. Now that I know that a equals 17, I'm going to take and substitute it back into the equation for a there. Now, most of my stuff is already filled out here, but let's go ahead and dress this up and make it look nice and neat. So whenever we write this equation, we want y and x to be left just as variables, because remember, it can stand for any point in the parabola. But the a, the h, and the k have to be filled out. So that's what I'm going to do now. I'm going to say, okay, y is equal to my a value, which is 17. And then I'm going to say, okay, we've got x minus my h value. The h value is 1, quantity squared, and then add that k value there. This is the equation of that parabola. Okay? So hopefully that wasn't too bad. Those were nice, easy whole numbers. We solved for a, then we substituted it back in and got our equation. Sometimes we have something that's not so simple and we've got some fractions involved. So I want to give you an example to look at here where we're dealing with fractions. Same process, it's just jogging your memory. Do you remember how to work with fractions? So I want you to take a look at this problem, pause the video once you see it, give it a try, and then come back and see how you did. Here it is. Write the standard form of a parabola that has a vertex at 1, 3, comma, that's negative 1/2 there. I know sometimes with a marker these things kind of smudge a little bit. And it's got to pass through the point 1/4, comma, 1/8. So it's the same process. Pause the video and give it a try. All right, I take it that you've paused it, gave it a try. Let's go through it together and see how you did. Once again, I'm going to label. I think it's so helpful that we label the x, y, and hk. Otherwise, it's real easy to switch the two. And it does make a difference which one we're on, or which one we label x, y, and which one we label hk, because you can mess up if you don't label it correctly. The vertex gets labeled hk. The point that's on the parabola gets labeled xy. And then we're going to substitute in. So my y value is 1/8. The a, of course, we don't know. The x value is 1/4. And then I'm going to subtract from that the h value, which is 1/3. Make sure you square it. And then we're going to add our k value. Once again, this k value is negative. It's not always negative. Just so happens to be in these past two examples. And now the rest is just solving for this unknown variable here of a, and then we can plug it back in and get our answer. So a little bit of fractional work here. To subtract these two, I need a common denominator, and that is going to be 12. I multiplied that 4 by 3. Got to multiply the top by the same. Multiply the 3 right here by 4. Got to multiply the top by the same. And we are going to square that. And then subtract, well, not subtract 1/2 from it, but tag it along there. 3 minus 4 is a -1. And it's over 12. Now, remember, when we square a fraction, we're going to square the top and the bottom. So I get 1 over 144 times a minus 1/2 here equals 1/8. And I need to add 1/2 to both sides. So when I add 1/2, I'm going to say 1/8 plus 1/2. Let me go ahead and make it eighths. So that way we can add them, have common denominators. If I make it 4/8, that's the same thing as 1/2. Notice I multiplied the 2 by 4. Got to multiply that 1 by 4. It's the same thing. 4 over 8 is the same thing as 1/2. And now I can add it to 1/8. So when I add 4/8 to both sides, I get 5 over 8 equals a times 1 over 144. Now, still solving for a here. Whoops, paper is wanting to jump off the table here. To still solve for a, I need to divide both sides by 1 over 144. Another way we can say divide fractions is to multiply by the reciprocal. So that's what I'm going to do here. Multiplying both sides by that cancels that out, and I'm left with a by itself. Why did I switch colors? I don't know, just so you can kind of tell the difference between the two. And when I multiply these two, remember, multiplying fractions, we multiply straight across. But to make life a little bit easier, if I can reduce ahead of time, I am. I notice both of these are even. So if I divide both by 2, I get 72 and 4 right there. Oh, 2 more even numbers. So once again, I'm going to divide them by 2. Or if you notice that 72 will go into 4 will go into 72, you could do that. But not everybody does. So divide both by 2, I get 36 over 2. Once again, I'm starting to run out of colors here to use. I'm going to divide this by 2, and I get 1, and divide that by 2, I get 18. So all that being said, I just get 1 in the denominators here, and so I'm left with just 18 times 5, which is 90. So that's what my a value is. 90 equals a. All right. Now, you do so much work, you feel like that must be the answer, but remember, it's not. It's wanting to know what is the equation of the parabola in standard form. So I need to go and substitute that back in for a in my original equation up here, and then make sure I have h and k filled out as well. So that's what we need to do. We're going to say y is equal to my a value times x minus my h value. My h value, remember, was 1/3. That gets squared, plus the k value. Now the k value here is -1/2, so I'm going to write it as -1/2 there. There's your equation. Okay? So hopefully that kind of answers some questions on how can we write the equation of a parabola if we just know the vertex and a point on the parabola. You got to substitute it into our standard form, solve for your a value, and then you take that a value and substitute it back in later on in the equation. It kind of reminds me of something we did with linear equations when you knew 2 points on a line and you had to write the equation of the line. One of the things we did was we substituted it into point slope form. We figured out the slope, and then we could go back and write the equation of that line. But you had to solve for m first. Here's kind of a similar thing, except for we're solving for a. All right? Give those examples a try, and let me know if you have any questions. Thanks for watching.